This is the section 11.7 presentation on finding the volume of the solids pyramids and cones. So volume again, just a quick review, is just the amount of stuff that is inside of a solid. So it's like three-dimensional area inside of a solid. The formula for finding the volume of a pyramid and cone are very similar to each other. Whereas we were finding the volumes of cylinders and prisms, it was area of the base times height. For pyramid and cone, it is 1/3 area of the base times height. So a pyramid could be a square, it could be a triangle, it could be a pentagon for a base. So you just find the area of the base and multiply that times the height and then divide that by 3. And then for a cone, it is area of the base, which is going to be a circle, so it's going to be pi r squared, times the height, and then divide that by 3. So apparently when you make a solid pointy at the top, you lose about 2/3 of the volume, which is kind of an interesting deal. So let's take a look at an example here. So here I've got a height of 5.5 centimeters, and I've got a radius of 3.3 centimeters. So this is going to be finding the volume of this particular solid, and this one is a cone, okay? So it's going to be the radius squared times pi times the height divided by 3. So those calculations are going to look like this. So 3.3 squared, which is the radius, times pi times the height of 5.5, and divide that number by 3 gets you 62.7 cubic centimeters. So really, most of this is just basically plugging in the formula and calculating the volume. So let's take a look at this one. So we've got a triangular pyramid. The area of the base of a triangle is 1/2 base times height. So the base is 6, the height is 4. So half of 4 times 6, so 4 times 6 is 24. Half of that is 12. And then I'm going to have 12 times my height, and then divide that by 3. So my calculations are going to be 12 feet for my base, and then 12 times 9 divided by 3 is going to be 36 cubic feet. All right, let's take a look at this one. So this one's a little bit more involved. It's going to actually be a throwback to a little bit of triangles when we used the Pythagorean theorem to figure out the side length of a triangle. So in this case here, we don't know the height, but I know that I've got a radius of 5, and I've got a slant height of 13, but Cavalieri's principle says we have to use the actual height, not the slant height. So I've got to figure out the height here. So like, what is the height? You'll notice I've got a right triangle here, so I can use the knowledge of the Pythagorean theorem to figure out the length of this height. So the hypotenuse of this right triangle would be 13. So when I set up the Pythagorean theorem, I can go 5 squared plus height squared equals 13 squared. There might be another way that you might have known how to do this. You might have recognized it's a Pythagorean primitive. This is a 5, 12, 13, in which case then the height of this particular solid is going to be 12 meters. And then I'm just going to fill in the formula, okay? It's going to be, because this is a cone, it's going to be 1/3 times pi times my radius squared, so it's going to be 25, 5 squared, and then times my height of 12. So my calculations look like that. And when I take 25 pi times 12 and divide that by 3, that's basically the same as 25 pi times 4 would be 100 pi. This would be 314.2 cubic meters. All right, last example. So this is a quick presentation because basically we're just plugging in the numbers to solve the formula. So a pyramid with a square base has a height of 144 meters and a volume of 2,226,450 cubic meters. What's the length of a side on the base? So I'm just going to fill in the formula, okay? This is a pyramid, so I'm going to be using this formula right here. 1/3 area of the base times height. So my volume is 2,226,450. And then I'm going to have 1/3 the area of my base, which I don't know, times my height, which is 144. So it's going to look like this equation here. So first thing I'm going to do is I'm just going to take 1/3 times 144, and that's going to get me 48. So I'm left with 2,226,450 equals 48 times the area of my base. So now I'm going to divide both of these by 48. When I divide both of them by 48, I get 46,384.375 is the area of my base. Now my base is a square, and because my base is a square, that's going to be side times side is calculating the area of a square. So in order to figure out this answer, I'm going to have to take the square root. So I'm going to take the square root of this number, which I just punch into my calculator, and I get 215.4 meters. So that's the length of one of the sides. And that's it. So that finishes off this presentation. For Wednesday, I want you to do page 766, problems 1 through 7 and 9 through 10. Don't send it to me, just hold on to it till you do Thursday's assignment, which is going to be page 766 through 767, questions 11 through 13, 15, and 16, as well as 20 and 22. And a little bit of a warning here, you're going to have to bring back some trig here for questions 15 and 16. So I'm going to expect you to remember how to do sine, cosine, tangent, to be able to figure out an unknown length to do a calculation to figure out volume. And that ends this presentation. I guess another forewarning, on Friday we'll just have a review assignment which will be posted on my website. So hopefully you found this presentation helpful for you. Thanks.